And for us, I think most of us are professionals, and even for the noobs, I think some of them have gotten their hands dirty with trying out pieces of code here and there, and we less look for excitement and more like what can I apply? Like this space is over, can I open my IDE, my Vim, or those of us who are on Emacs and actually address an issue? So, and that's why I called it old guard, because the goal is to just look at the tools that we have to deal with on a day-to-day basis and find ways to have the best output from those tools by us sharing knowledge amongst each other. So that's the whole idea. We might not talk so much about new and exciting tech, although that might be part of our discussion. But the whole philosophy behind the space is, yeah, even guys in the JavaScript space where frameworks are released every week, yeah, they are released, but your company would adopt it that day, so you probably still on your Angular. So Burn might be out, or there might be Vue.js, but your company still has that legacy code base that's running Angular 1.0 or 2.0 or something. So it's still in a space where you can discuss such things, and that's the purpose of this particular space. So I think we can start by first introducing the speakers, and then I'll introduce the topic of today, and then we can pick up from there. So maybe I can start by introducing myself. My name is Samuel Owino. I'm a software developer, software engineer, coder, whichever those titles mean, because I have never really understood what they mean, but I prefer coder because it's more like the verb of what I do on a day-to-day basis. And I've been doing software development or coding for close to 8 years now. I think more than 8 years. I work mostly in the mobile space, Android, iOS, but my career has been mostly on Java. So I do a lot of backend stuff with Spring Boot and Spring Framework and the rest of that. Early years on my career, of course, I did some desktop with Java. Any of you guys here know about Swing or JavaFX? I played around with that quite a bit. And yeah, I'm really looking forward to us sharing knowledge in these and upcoming spaces. So Enoch, Mr. E, I think I can give you a chance to introduce yourself, what you do, and yeah, what excites you about software development. Hey, Enoch, I think you're on mute. So okay, we might not have Enoch yet. If you're having an issue, oh yeah,
I'm honored to appear for this space for the very first time.
Yeah, there's a bit of some interference with your connection, but maybe if you could just repeat the introduction. Can you guys hear Enoch? Yeah, Enoch, there's a lot of interference with your connection. Can you try and switching providers or something? I think I'm having trouble hearing you. Maybe I can proceed to Joe as I give you a chance to maybe look into the connection. Yeah, yeah, it seems to be a mic issue. Give it another try. Oh no, I can't hear you. Anyway, I think we'll just proceed to Joe, and maybe Joe, you can also tell me if maybe the issue is just on my side, if you guys can hear. So Joe, maybe just introduce yourself, tell us what you do, and what excites you about software development and the work that you do. Thank you. Hey Joe, we can't hear. I think you are still on mute. If anybody can hear Joe, maybe wave so that I establish that probably in case the connection is on my side. Can you guys hear me? If you can't hear him, do a thumbs down so that I know. Anyone? Derito, Ronnie, can you hear Joe? Oh yeah. I think we can't hear him. Oh yeah. Thanks, Ronnie. Thanks, Ronnie. Okay. I think my speakers are having issues with their connection. So Joe, if you come back on, just wave and be able to I will be able to establish whether. Oh yeah, I think he's on. Okay. Joe, once you're connected, just proceed. Okay, so as I wait for this, I think I can just introduce the topic, and then once they fix the internet connection issue, we'll be able to proceed. On our first episode of OldGuard, the goal is to discuss performance tuning. Performance tuning is a robust topic, so I suspect it will stretch beyond this particular space. Um, Yeah, so I suspect it will stretch beyond this particular space. But on this first episode, I was just hoping that we could cover. Oh yeah, we can hear you, Joe.
Refusing to join. I don't know why. The microphone. Okay. Yes. My name is Joe Mwangi. I'm actually a scientist on industrial chemistry background. I work for the Ministry of Energy on matters of nuclear energy, but programming, I've been doing it as a hobby in a way for quite a while, maybe around 5 years. And mainly my work is in 3D applications. And my specialty actually is to develop ray tracers and also path tracers. When you see those Pixar movies, the way they make 3D characters, etc., the software I'm trying to make is along those lines. So I've been trying to use Java to utilize the GPUs in your laptops, computers, etc. Quite powerful processors that we never utilize as much as possible, both because the applications mostly we use don't utilize them. Applications such as Photoshop and many 3D graphic softwares do actually utilize GPUs, but for doing calculations, data processing, etc is it can be actually be done through GPUs. So I've been trying to find ways to do data-oriented programming between Java and the available graphic device in modern computers that exist. So mainly I use OpenCL and Java to do such kind of computations. I'm yet to join CUDA. CUDA is another one by NVIDIA. And actually they do produce the best GPUs in the world at the moment, but they cost a lot. So mostly I use Radeon graphic processors. So maybe along the way, I'll be talking on how Java, Panama, Vector API, and the future value types will actually make Java programming with GPUs become easier. Thank you.
Yeah, thank you so much, Joe, and thank you for honoring the invitation. So Joe will tell us a bit more about what he does, and that will be a nice segue into. I've been talking with Joe a few times on the TL, so I'm kind of familiar with the work that he does. So I thought, the domain that he's in is, it's hardware intensive. So having him around to tell us a bit about performance tuning, I think he's working in a domain where that's a critical component. And we'll hear more about the work that he does. Mr. E, anytime you fix your connection, I think you can just request the mic. I have seen you've moved from speaker, but I'm guessing you're trying to figure out your connection. But once you do, just let me know. Anybody else who wants to speak, just request the mic. I'll be more than glad to give you a chance to tell us a few things. So I think I'll just proceed to introduce the topic. So today's topic is performance tuning, and I thought maybe I can say a few things about it and how various people approach it, and then from there we can expand. I just received a request here. I don't know if it was from where it was from. Oh yeah, I can hear you. I can hear you. Oh yeah, I can hear you very well. You can proceed. You can proceed.
Okay, thanks very much for the chance, Samuel. My name is Enoch, and I'm honored to be in this space today. A little bit about myself, my background is that I've been a software engineer for a couple of years now, 10 years to be precise, and I'm currently a CTO at a betting company. And I believe part of my contribution to this conversation today will basically be talking about performance optimization and looking at the current disposition that I'm in. There's a lot of performance tuning that comes about, especially when dealing with finances and streaming of money that comes in by the second. Yeah, so I'm looking forward to giving a talk that has much insight on how to work with money, and in this instance, a lot of it that is being transmitted digitally through devices, and this is from USSD, web applications, and Safaricom's SIM toolkit.
Awesome. Thank you, Enoch, for that. So as you guys can hear, Enoch also works in a place where, in a domain where performance issues are a key consideration. So I think they are good speakers to have today, and I will be asking them a few things about the work that they're doing, and maybe they can give us a few insights. I'm sure there are people in the who are also listening who are also working in some of these domains. So I think most of you guys will be interested to hear about various approaches that are taken in performance tuning. Yeah, so just to introduce the topic. So performance tuning is one of those terms that there are those aspects of software development that you never worry about until it's too late. There's a common funny phrase that when you go to a dentist, it's already too late for you. They'll have to remove your teeth because you should have been brushing your teeth every day and getting it checked out on a regular basis. So usually for most software projects, they usually wait until maybe the server is overloaded and they are dropping requests, or if it is on mobile, they're running so many operations that the platform is barely usable. That's when now they start thinking about, oh yeah, we need to fix these performance bottlenecks. But the best way to approach performance tuning in software development is a more proactive approach, where you will make sure that the system at any instant is more than ready to scale to maybe the number of requests that you need to process. In case you have a burst in traffic, like there was an incident where there's a pizza shop, I think in the US, where Messi went and like took a selfie of him eating pizza there. All of a sudden, these guys didn't have any more pizza to sell because they had like a huge burst in traffic. I think that's usually a common case in software development where people deal with performance tuning when it's too late to deal with it, because by the time you're dealing with it, you've already lost potential clients. Maybe people are not able to access the service that you're offering at the time when they actually had an interest in accessing that particular service. And I think the reason why performance tuning is usually given a backseat is because of, I think, about four common arguments. Number one of them is most software developers believe there is no need for performance tuning. And this no need argument comes from, the hardware that we have currently is so advanced that regardless of how quote unquote how stupidly you decide to write your software, it will still be able to perform on the hardware because the hardware is just that good. I think we saw Apple launch the iPhone 15 Pro, and that small phone has bigger hardware or greater hardware than most high-end laptops. So if you're running a mobile application, which from the ground up is built to run on constrained environments, and then you're running it in such an environment, I mean, regardless of how much it might end up not being tuned, it will still run very fast in such an environment because like I said, the hardware is just that good. So a lot of software developers argue that essentially there's no need for performance tuning because the hardware has really evolved. That most platforms where you think that you have memory constraints or CPU is not that strong, or maybe you're trying to preserve battery, which has been the tradition in mobile development, that need is no longer there. You have bigger capacity batteries, you have faster CPUs, you have a ridiculous amount of memory. So most software developers look at that and they're like, oh, we don't need to do performance tuning. But of course, the argument is wrong because if you're building for the globe, not everybody can buy an iPhone 15 Pro. So, if you're trying to build for everybody, then you have to consider devices that don't have that hardware specification. So that that eliminates that argument of there's no need. The other argument is usually the difference in performance is too small. The weird thing with performance tuning, you'll spend an hour on trying to maybe optimize memory usage, and by the time you are done with that optimization step, you'll have maybe increased performance by 2% or 1%. So they're like, oh, the change will be too different. So why spend energy and time doing that? And the argument against that is that scales. So if you're able to read the records from the database 2% faster, if you're reading 5 records, yeah, the performance is not that significant. But when the user has maybe 10,000 records, now you start seeing the advantage of having done that optimization because it's exponential. So the benefits increase with the amount of workload that you have to process. So of course, performance tuning is costly in terms of engineering hours because you are spending time that you'd otherwise spend on building new features. And I think that argument will fall under technical debt, where when you're evolving a software system, you have to consider how much technical debt you are accruing as you're adding these new things. And performance tuning, I believe, becomes part of that technical debt. So it's something that you need to come back to optimize your system because you cannot just be adding things to the software system. You have to come back and do optimizations. And on the cost bit, the challenge is usually convincing your manager that you're going to take 2 weeks and you're not going to add anything new on the platform that will excite customers, and instead, the product will run 2% faster. So it becomes a challenge to explain this to managers and have them understand that you're doing this proactively for the time that you don't know you need it, but you might end up needing it. Like when Messi comes to your shop and takes a selfie, and suddenly you move from 2 requests per second to like 10 or 20. And your system, if your system is not ready for that, then it becomes a challenge, and the manager loses more revenue than they would have saved if they kept you from doing performance tuning. So I think I hope that small intro kind of gives you guys, I think, my perspective on why this topic is important. I could go on and on about the arguments back and forth regarding performance tuning, but then I think I'll go over to Joe to tell us about the kind of work that he does, um, which performance tuning challenges he has faced, and maybe give us a few tips, Joe, on how you've addressed some of these challenges. But you can start by generally introducing the work that you do and what kind of performance issues you have to be aware of during your work.
Okay, thank you very much. So for me, 3D modeling and rendering is a passion that I have. Actually, it's usually like a hobby in a way. And when you're dealing with 3D models, you're dealing with large sizes of files, which can even go to gigabytes. And actually, most of them are usually free. You can actually download them. Even the ones you see, like the Moana movie, the island itself is actually the whole model is actually available free online. And it's usually quite huge. It's around 37 GB. So in this case, we are dealing with a lot of data. And since I do programming with Java, Java has limitations in terms of sizes of data it can actually accommodate in heap. So an issue with Java is that the objects tend to have an attribute called an identity, whereby an object has information about itself. For example, if you want to do synchronization, if you want to do polymorphism, if you want to actually compare one object with the other, Java tends to have some additional information. The Java objects tend to have additional information so that a programmer can be able to actually undertake such kind of functions. So that's how it started actually back in the 1995, back in the day, because primitives and Java objects writing, reading was quite the same speed. But with time, the architecture, CPU architecture, and also GPU architecture actually progressed in terms of dealing with data. And for example, if you are dealing with a variable like an int, that's one variable. That's how it started. But nowadays, GPUs and even CPUs can read like 4 ints at a time, or even 5. Actually, the maximum I know is around 256 ints at a time. So Java, for that, you have to use arrays, and it becomes a bit of a complex to actually deal with such kind of data. So issues such as encapsulation, whereby the programmer tries to avoid mixing reading. Maybe you write an int value, and then you try to read a long value from the same memory address. It actually encourages a lot of data corruption when you're dealing with memory from the off heap. I don't know whether I'm afraid to be more complex a bit, but yeah, there's an issue of data corruptions when you're programming as a user, and those bugs can be quite a headache. Actually, I know most of you have experienced whereby there are some invisible bugs that you discover maybe after 3 weeks. It was just a simple writing or reading of memory that you had actually programmed it in a bad way. So yeah, I later on, okay, when I decided to create my first ray tracer, it was a CPU and it was quite slow. And then later on, I tried to learn about how ray tracing works. I didn't want to go to rasterization such as OpenGL, DirectX. I thought those were quite complex for me. Ray tracing was more like math-based calculations on how you adjust light, how you can accelerate it, because rendering like a huge scene requires some very clever optimizations. So later on, I discovered, the issue is actually arranging your data in a unique way and then trying to execute a stream of data all at once. So Java was more of a like you couldn't what do you call it, parallelize it properly. So I thought maybe I could look at other architectures like the OpenCL, which is a GPU way of programming GPUs. It's a way of programming GPUs. It's like C actually. And when I was able to make my first program to do that, I was actually amazed on the possibilities that I could do actually. And then later on, I discovered the way Java actually stores memory data in memory. It's not the way GPUs would want that data to be represented when being given when you are transferring from the Java heap to the GPU. So later on, I discover off heap is very important. And then looking at what Java had, I discovered there are some classes that are forbidden, like unsafe. Unsafe is actually unsafe is class is one of the most famous class in Java that is being used everywhere. For example, the atomic classes in Java are based on unsafe, and then what else? Byte buffer neo libraries, the one for buffer for storing data in terms of buffers. They use the unsafe class, and actually you discover that the Java architects who made Java, like is it Gosling, knew that they needed a way of actually finding a way of actually representing data in a very efficient way. So that's why we have Java primitives like int, float, double, char, etc. They were actually created because of speed. And later on, the Java objects, and then Java objects, which are not quite efficient, but but they could be of use for representing data in a unique way. So in early, I think 2009, the Java people discovered that they need to find a way of actually re-architecting the Java virtual machine because the way it's made is that they want to target hardware. There were some various attempts like the Neo buffer system. It was their first attempt, which never went really well. And then later on, I think early 2010 is when Valhalla was conceptualized. It's almost like almost 10 years or 13 years. We haven't seen the Valhalla being released officially like a preview feature, but it's heading there. So for me, building my ray trace, I discovered that the files that I can manage to load in my program, the maximum I can go at the moment right now it's around 2 GB. That's it. And when I load a model that is around 2 GB, my computer sometimes hangs actually. So I'm planning to upgrade even the hardware. For example, my RAM is 16 GB. I want to go to 32 GB, and it's a bit expensive in a way. But with the projects like Project Panama is a way of communicating with other languages purely using Java. You're not going to write any C code or anything. You just use pure Java. The Java native interface was actually implemented since Java 1.0, and unfortunately, it's prone to errors, and also for new programmers, it's quite difficult to set up a Java program that can communicate with native functions. So Panama tries to bridge that gap, and arrays in Java have a limited count. Yes, because if you want to state the size of a Java array, the maximum is the integer type dot max value. And if you are initiating an int value, an int array, the largest size of array you can make using the int array is using the integer variable, it's 8 GB, because the 2 GB times the 4 bytes is equals to around 8 GB. But if Java could have started using long variable to define the size of an array, we can go to sizes of around exabytes actually, and that's what they are planning. Panama has actually introduced such a feature, and that's what I actually want to utilize. So hopefully one day maybe I'll be able to use the current hardware I have so that I can load larger scenes, and maybe they will introduce more hardware specific types like float 4, int 2, int 4, etc. And that's where value types will come in. And there's also vector API. Vector API is targeting your CPU. Your Intel Core, or maybe your Apple computer usually has vector processors, so they can handle that a lot of data at a time. But it's for you, the programmer, to utilize that hardware architecture. So Java, they introduced the vector API. I haven't used it yet, but I've seen on Twitter some people posting their benchmarks. Like there's a guy who posted on Twitter that his program using the language, the machine learning llama, they were able to actually beat the current implementation using the C language. And actually, the conversation, if you could have seen, people were wondering how come Java is faster than C. But the guy later on said that his code is written in vector API that Java is trying to introduce. So I hope such features I'll be able to integrate in my application and make 3D applications. In terms of my work, I like doing Monte Carlo simulations. For example, if I want to simulate neutrons, maybe the subatomic particles, they require a lot of processing in parallel to make them the simulation efficient. So that's my future goal. And in terms of data analysis of data, maybe reading data from the disk and then also doing some processing and then displaying the data in terms of maybe there's some objective I want to meet. The GPU, the parallel programming, will actually help a lot in that. So it's more like an intriguing thing for me to look at and see whether maybe in future most of my programs will be focused on parallel programming model. The Brian Goetz, the architect of Java, he actually uses the term data-oriented programming. Here, we are not thinking about classes, we are not thinking about objects, we are thinking about data. That's why you hear Java nowadays has records, and then in future they will have value types, and then now pattern matching on how to handle data. So it's a way of the way Java is going. They'll focus more on data-oriented programming. Yeah, thank you.
Thank you so much, Joe, for that insight. Is there anybody in the listening who probably has a question for Joe? Just request the mic and let you maybe address your question. As I wait, I think I can address a few things that Joe has mentioned. For people who are not in the Java ecosystem, but most of the things that Java is handling currently are not they're not 100% unique to the Java platform. I think it's only that Java has really focused on this as the approach. I think, and you must appreciate the focus. I think that this started from Java 8 when we got streams. So I'm sure everybody here, even if you're doing PHP or you're doing Kotlin, you likely interacted with the streams, and maybe your particular domain it's handled a bit differently. But the idea starting from streams was to convert Java into a purely almost 90% object-oriented language, where the main goal was to allow you to emulate real-world objects in computer programs. I think that's how I looked at it. So you could represent a cup as a class, and you could present a house and the rooms inside as classes and subclasses, and you could do inheritance, and then you just have operations within those classes in form of functions to kind of give operations or functions to the objects from the real world that you've decided to represent in your program. A more realistic case would be you go to an organization, you look at the organizational structure, there's C-level executives, there's employees, there's supervisors, and they're like, okay, do an ERM system, an enterprise resource planning system for us, ERP system. So you'd look at, okay, you guys you have a store, you have inventory, you have stock, you have suppliers. Okay, so I'll just create a class supplier, class inventory, class store, class executive, class manager, class supervisor, and then compose the relationship between those particular parts of the organization in terms of inheritors. Maybe a manager inherits from executive, or employee supervisor inherits from employee. I liked that kind of way of representing computer programs, because you could just look at what you're being told to program and have a direct mapping of what you're told to develop from the real world into your computer program. And that was great. But Java is moving away from that a bit, kind of retaining that aspect, but also expanding into now data processing, just like Joe mentioned. So, in every organization, you have data flowing through. There's reports, there's sales data, there's, if you're maybe in my domain, maybe you're tracking usage analytics. So all this is data that's flowing within the organization, and you need a way to process that data. Maybe take it from one form and represent it in a different form. Maybe take it and generate reports, or maybe take it and compose it into a way that it can be stored into a particular type of database. And the Streams API was basically built for that. And it was, it was on point, because as software engineers, that's ideally, in most cases, unless you're building UIs, if you're building organization-oriented software products, you're likely doing some data processing 90% of the time. So having those APIs really made Java an attractive language for that. And even with the projects that Joe has mentioned, Project Panama, Project Valhalla, which I'll mention a bit from guys coming from the JavaScript, TypeScript ecosystem. I think you guys can relate with what Joe was mentioning about value types and object types. Basically, before, I think the main difference between TypeScript, and anybody in the audience can correct me, the main difference between TypeScript and JavaScript is TypeScript offers adds a type system to the language, and the old JavaScript, if I can call it old, because I'm sure a lot of people are still using it, was object-based. Everything inherits from object. So the fact that it's object-based means anything you create in your JavaScript program has to acquire a certain amount of memory within maybe the browser or whichever runtime it's being executed in. So within the Java ecosystem, we kind of have the same. We have object types, but also we have primitive types. So primitive types inherit from C. So they map directly to memory. So they are not stored in the heap. So remember, like the C arrays, where you have a primitive int in Java, you'll have a primitive int that you can map directly to the hardware, but also you have an object integer that will live in the Java memory heap. So with that you get a bit of performance gains when you need to work with primitives. The project Valhalla, I think, if not Panama, I think it's Valhalla. The project Valhalla is trying to find a way in which you can do a representation of objects, like I was telling you about the supervisor, the employee, but now you present them as primitives. So instead of having a large integer that eats up a bunch of memory, like she was mentioning, when he's doing his programming, those objects eat up a bunch of memory. You can have the same representation, but now it's a primitive representation. So it's like you're doing C in object-oriented programming. If you guys can remember, C only supports imperative type of coding. So that's generally where the language is evolving. And I think I'm curious, so that I've not gotten a request for anybody to speak about this, but I'm curious if there's any in other ecosystems like the Ruby world, Enoch, like in the mobile world, if you guys are seeing any of the similar transformation, if maybe the language design is going into more low level, which I think is the direction that Java is trying to go into by maybe removing JNI. Now we have a direct mapping to writing directly to native APIs. If you guys are having more data processing APIs, like I mentioned with streams, what Joe mentioned with the pattern matching in switch expressions. Are you guys having this kind of transformation, or are you still going more into the object-oriented style, which I think that's the direction JavaScript is taking? I mean, moving from the plain vanilla JavaScript into having TypeScript where you're presenting things based on type. Is there any initiative to add more data processing APIs into the language? If you want to speak on this, you can just request the mic before I hand it over to Joe to answer the next question that I have. So anyway, as I wait for anybody who will request the mic, so as we continue to talk about performance tuning, I think there are some steps that Joe has mentioned that I think we can note and maybe apply in our day-to-day. Through his talk, he talked about the steps that he took, identifying a performance issue and developing a fix for it, looking at how much memory is being used, getting the actual numbers. I think one thing we're able to pick from Joe is he knows how much memory is being used by the objects that he's creating within his program. And if any of you are wondering how that's possible, there's an aspect of performance tuning called profiling. So when you do profiling, is you run your program the way your software, your program the way you normally run it, but then you run it with an extra. Oh yeah, I'm seeing a request here. Let me just. This will take a bit of getting used to. I don't know where these controls are like hidden. So I'm seeing a request to speak from you, Enoch. Let me just figure out how to like enable you to speak. Oh yeah. Okay, I've added you to speak as Enoch. Let me know if you're able to get the mic, Enoch. Okay, I've sent you the invite. That other one didn't go through. Yeah, let me just see if you're able to accept it. So I was talking about profiling. So basically, you are running your program, but there's an additional program that's running parallel to it. And what this program does, it monitors memory usage, CPU usage that your actual software is consuming, and it kind of captures that data and it's able to present to you either at the end of execution or during execution. Guys who are doing Android development, you guys know within Android Studio we have a profiler, so you can run the app directly to your device, or you can do profiling, and as the app runs on the target device, it could be an emulator or the physical device. On the Android Studio dashboard, you'll be able to see the CPU usage, you'll be able to see the memory usage, and from that you can get the actual data. Beyond that, you can like scan a particular snapshot of the execution, and you can see, or I'm instantiating this object, and this object is currently in the heap, or this has exited the heap, or when I click on this operation, this is the amount of memory that's picked up, this is the amount of memory that's released. And from there, you can see where the performance bottlenecks are, and now you can optimize your program based on that. When it comes to memory leaks, I think there's a framework and app that I don't know if it is Twitter that did this. And Director, you can correct me, or Ronnie, anybody in the Android ecosystem. But there's like a framework where you add the dependency to your project, and then when you execute it, whenever your application has a memory leak, it kind of stops the execution of the app, and then it gives you a notification, and then it gives you the heap dump. Basically, it's like a log of where the memory leak has happened, and kind of gives you a trace so that you can trace that and maybe develop a fix. I've forgotten the name, but I have it in one of my projects. I think I'll check it out. But basically, there are tools like that that you can run alongside your software product, and they monitor the execution of the program and tell you when a memory leak has happened. I see you're still having challenges. Let me see. I think it's your network or something. But I see still having a bit of challenges. Let me know when you can be able to access the mic. I've sent you another invite. Let me know if you get it. Okay, so just a bit more on profiling and benchmarking. So within the Java ecosystem, we have the Java Flight Recorder. So you can run the Java Flight Recorder. I think it's done by Oracle, and it does the same thing that the Android Studio Profiler does. As the program is executing, it looks at how much memory you're using, how much CPU you're using, how many objects you have stored in memory. And from there, you can like trace and find bottlenecks. Yeah. So the other way you can be able to do performance tuning is through algorithm efficiency. You had Joe talking about choosing the correct types to use. So if you're more keen on like when should you use an array versus when should you roll out a list, or when should you use a set, and be aware of how that affects the performance of your program. That's one way you can look at it. You can also look at how long it takes to execute particular blocks of your program. This is my favorite. So what I usually do is I do a timestamp at the start of execution of my program and at the end of the execution of my program. And at the at the end of the execution of the program, I calculate the milliseconds used to execute the function. It's very rudimentary, but it gets me to determine at which point, or rather which functions within that section of the program is taking the longest to execute, as opposed to running a profiler. The problem with profilers, they also eat up some memory, so they might end up infecting your final data, because they are also programs. So if you are running in a memory constrained environment like on mobile, you might get like results, but then the results are also infected by the amount of memory that this profiler was using to stream the data back and forth from your program to maybe the tool that you're using to observe the execution. So profiling is one of the key things. Of course, minimizing unnecessary operations. So this comes from dead code. As your software evolves, you end up accumulating a lot of things that you wrote up and stopped using at some point, and you're not aware of, like, within the chain of execution, it never gets to that function that you wrote maybe 5 years ago. So being able to identify dead code and get rid of that, and being able to identify rudimentary steps that you have within your execution flow and removing those, so that your program is not wasting time on things that are not necessary, I think can be of great help. Of course, that falls under reducing redundant calculation, and of course, memory management, as I mentioned. So I'd like to give one more example on a performance enhancement issue. And this one is more server-side based. And it comes with processing HTTP requests. So if you guys are familiar with, if you're writing any endpoint, either REST or GraphQL, or any endpoint on your server that's supposed to receive incoming requests, I think the greatest fear that we usually have, although you're like, oh, the framework will take care of it, but the greatest fear we usually have is, okay, yeah, I mean, I'm testing it with one request or two requests. What if there's like a million requests coming on this one endpoint? So like, will I be ready to process all that data? And there are multiple solutions that we usually put in place as software developers. One of them is event sourcing systems. So one that I usually like doing back in the day was run an event sourcing platform like RabbitMQ or Kafka within the same server environment. And when a request comes, you don't process it immediately. Instead, you take it and you put it in the RabbitMQ queue. So it's queued up, and then there's some other section of your program that's waiting to receive those processing requests. And when within the queue, when their turn comes in, your system picks it up and it's able to process it. So it could be something like maybe processing a new registration. So somebody has registered, or some new data has been sent from the client. So instead of trying to get a database connection immediately and store the data before you return the response so that that thread is freed, instead you take that request, you put it in the RabbitMQ queue system, and then the RabbitMQ will figure out a way of bringing it back to some other end of your program. And then that request will be processed there. So the advantage there is when the request comes in, the thread that was used to receive that request is released immediately, because you respond to the client like, oh yeah, I've received your request, and then you can communicate to the client later through a push notification system. I think on mobile we have FCM, Firebase Cloud Messaging. Previously we had GCM, Google Cloud Messaging, that of course later became FCM, and then you can use that to notify the client that that request that you sent me 10 minutes ago, yeah, I've finished processing it. So the client is not waiting for you to do processing. And there's some performance advantages that you get from that. Another strategy is to have asynchronous endpoints. So in Java, we have something called completable future, and you can actually set your endpoints to return a completable future. So what will happen is when a request comes in, it will be placed on a thread, like on a queue. And then if another request comes in, another thread or queue is assigned to it. So you're not blocking new requests when you have others waiting. There's a bit of mechanics that works there, but we've gotten some enhancements with the virtual threads that's coming to Java that should enhance that workflow. So if you find a way of doing multi-threading within your endpoints, I think that's one way to address that issue. The last one is doing in-memory caching, and this is the recent one I've explored. So you have Redis running within the same server environment. So if somebody is trying to access data that you already have, I think this one is mainly for reducing the amount of time, the amount of cases where you request a heavy resource like a database connection. So when a request comes and you have to maybe it's a request to store some data or access some data, and every time you're creating a new database connection, those database connections are expensive. They eat up threads and memory and stuff like that. So you want to limit how much of that you're using. So what you do is, if there's some data that's constantly being accessed, you take that data when it's accessed for the first time, and then you put it in Redis, the in-memory cache. So when a subsequent request comes in with the same request for the same data that has not changed, maybe it's a user record, then instead of creating a new database connection to access the data, you just hit Redis, because Redis is in memory to respond immediately, and then you're able to respond to the client almost instantly. So I think on the server side, those are the ways that with time I think the few ways that I've learned to do performance tuning. I'm still trying to get Enoch to be able to speak, but hey, Enoch, your network today, man. Yeah. So I've just approved you. Let me know if you're able to. Yeah. Let's see. Yeah, I'm approving you, Nini, but it's just keeps disconnecting. So if anybody in the audience have a question, or if you want to chip in, you have some thoughts. Okay, so I think I'll take it back to you, Joe. And what I'd like to learn from you is what kind of tools are you using to do profiling or optimization? As I try to see what it will take to enable Enoch to speak. Enoch, I've just enabled you again. Let me see if you're able. Yeah, so once I enable you, you get dropped off. This is very strange. Oh. Okay, I've sent an invite. So anyway, as I try to get Enoch on, maybe Joe, you can tell me about the tools that you're using to do profiling, or if there's any tool that's assisting you with performance tuning that some of us can jump into and use it to monitor the performance of our existing products that we're working
on. Okay. Actually, I don't use Profile as much, but the one I mainly use is the
Okay, I'm
one
loudspeaker.
in
Can you hear me?
Oh, sorry.
Yeah, proceed. Proceed. It's difficult getting you on, so yeah, just proceed, Enoch.
Okay, let me proceed. So I believe you had inquired initially if at all there is any advancements in Ruby that cater to matter scaling and the like. I can say that currently the latest stable version of Ruby is 2.7, and the legacy versions are pretty much receiving support from various factions of the community. In Ruby 3.0 going forward, there's been several changes in terms of speed and providing features that do allow Ruby to be a programmer's favorite in different instances. Now, there's this notion that's normally said that Ruby doesn't scale, and unfortunately, once somebody finishes saying that, they head and commit their code to GitHub, which surprisingly runs on Ruby. So at our company, which is a lottery company, we run Ruby on our backend, and when it comes to the tooling side of things, we use Redis. Redis is an install, it's an in-memory data storage database that allows us to do caching. Now, caching in our instance is used majorly for users who use the web application, and the web application in this instance just doesn't need to be making requests to the database all the time. When a user gets to sign in, if at all they had already loaded the site on their device initially, Redis just serves that data to them without having to hit the database again. So basically, it makes the application have a more pleasant experience for the user who's using it in this instance. And at the end of the day, having that user experience whereby there could be things that need to be fetched, and that is, they are only fetched when it's necessary. If something like the header had been fetched initially, it doesn't have to be fetched again. Yeah. So those are some of the instances whereby performance optimization comes about, and caching has been a very integral part of our ecosystem in regards to making the user experience be something that is very pleasant. Now, when it comes to finances, there is one thing that most developers normally are not ready for, and that is when you have an influx of users coming into your system at one go. So, an example of this is for us, we had to be prepared from the very start. We knew that we wanted to serve a huge market, and from day one, it meant that we were going to be on radio. So the moment we advertised on radio and TV, that first week, I think we were collecting like around 25 million. And initially, when designing the system, that had to be a factor that we had to really consider in regards to the design of the system. So we designed the system using a message queue. And a message queue in this instance, basically, if at all you do understand the queuing data structure, when you're studying data structures and algorithms, this is where it came into place. Now, we were not going to sit down and develop a message queue from scratch, so we settled for one of the message queues that exist. An example of a message queue in this instance would be something like Kafka or RabbitMQ. There's also ZeroMQ. But in Ruby, we do use a popular framework known as Sidekick. And Sidekick came into play when we needed to serve our audience who basically use the Safaricom SIM toolkit, and also those ones who use USSD. And for these users, what happens is that the message queue, like now on day one of launching the application, the message queue came in handy, processing like about uh, this was like about 200,000 requests. Yeah, just queuing them and processing them in the background without the servers being overwhelmed or anything crashing. So in this regard, Sidekick as a message queuing service came in handy with Redis, the insta memory. the in-memory data store, that is. And the two played along so nicely in regards to making sure that the user experience was nice, because you don't want to have one of those phone calls that tells you like, yo, what's up? I played the lottery and I haven't received my ticket number via SMS. And that becomes frustrating when now the calls amount to, say, 30 calls within a certain period. And 30 calls got to go through all at once. So some users normally turn to social media and start throwing insults or start tarnishing the name of the company, claiming that they've played and the company hasn't sent them a ticket number, and it becomes an issue altogether. So having started out with Redis and Sidekick MQ from the very beginning really saved us a lot in regards to solving this kind of potential problem that we had foreseen. So I'd say at our company, the biggest form of performance tuning basically comes about with caching and using a message queue to serve and run things in the background. I think these are the major performance kind of optimizations that we had to make on our end. And along the journey, other methods of figuring out how to optimize our system for speed and efficiency has been basically using a logger, not something that not reading the logs in themselves, but using something like, I don't know if at all any of you has come across App Signal or something like Sentry, or in this instance, Datadog. Yeah. So there's also Honey Badger and the likes that do help you figure out where in your system you need to make the necessary performance. A majority of the performance issues that we've been having basically have been database related, and this is in regards to queries and selecting winners. So you always have the n+1 problem when it comes to databases, whereby you are trying to make a query and the query has an n+1 issue. So when you're using something like Datadog or Sentry or AppSignal or AppTrace, this software basically help you figure out where in your system you are experiencing optimization issues. So when it comes to database issues, it will tell you like, okay, there's this database issue that's taking long to run. It takes like about this number of microseconds. You could tune it and bring it down a little bit. And that one kind of like assists us and the team that we have at our place to optimize the workings of our system altogether. And it has been a successful journey so far. And I think that's all I have to say about uh, optimization and productivity. Yeah, thank you very much.
Thank you so much, Enoch. I think that's very insightful. I've learned a lot from some of the things you mentioned, and I think I'll be trying out a few of them, especially the logging one. I've been doing in-memory cache. The funny story, the reason why I started using RabbitMQ was because of M-Pesa, that that dreadful M-Pesa API called Raja. It's dreadful because you never know how it's going to respond to your system. So with the M-Pesa API, you have that. You usually have a callback URL that you give them, that you provide for them when you do an SDK push, and within that callback URL, they respond when they want. So you'll receive a request on your server for somebody wants to pay for something, and if you block the thread waiting for M-Pesa to respond to you, you might block that thread for like the whole day or for as long as you're able to hold, because there are some days that they just go off and they don't respond to those requests. So then I was like, okay, because this thing is going to freeze up my system, let me receive those SDK push requests that I've already placed and just put them in RabbitMQ. So when or in this case, somebody can be using Kafka, any event sourcing system or message queue system. And then when M-Pesa finally responds, now you can start doing the processing so that you're able to release the threads and be able to handle some additional requests. So thank you so much for that insight. I think these are practical things that some of us can even look into and and start using so that we're able to have reliable systems. I like that you also mentioned that if this doesn't work, you have outrage from the customers who might go online and start attacking you. I see that on guys like us who are on Google Play and App Store. You wake up in the morning and you have a 1-star review. Turns out your CPU overclocked last night and the server went off, and the whole time you've been sleeping, your server has been offline and it didn't know. So you wake up in the morning and you find emails and 1-star reviews on the store. So being able to proactively approach performance tuning, I think is very important, especially when you're running a system such as what you're working on. So I think on the replies, I've linked a few of the things that we are discussing, and I'll continue to link them. I was just getting the link here for Apache Kafka, so that once this space is done, you guys should have something that you can already get your hands on and start practicing with. Also, looking at the replies, some useful comments from Ronnie and Derito. Yeah, that memory leak tracking app or platform for Android is called Leak Canary, done by Square. I think that's why I was confusing it with Twitter. The former CEO of Twitter, Jack Dorsey, is I think a CEO or shareholder in Square or something. He just promotes it. So there's a bit of a relationship between the old Twitter and Square. Otherwise, anybody in the Android ecosystem should know Square. They basically build the Android ecosystem for us, from like database systems and the rest. So it's called Leak Canary. Thank you so much, guys, for highlighting that. So I think since we've already heard from Enoch, I think I'll take it to Joe to proceed from something he was talking about, using profilers. So Joe, you mentioned that you don't use profile benchmarking and profiling systems. So how do you get your statistics? How are you able to determine that, using this data structure, I'm able to improve the performance of the system by this scale, or this is where the performance bottleneck is? Can you give us some few insights on how you approach that? Because I think observability is very important. So how are you able to tell when you have a performance issue and where to strike so that you address it?
Okay. So most of the time, actually, I work with OFIP data. So there's a way I can be able to. Okay, there's some small functions I've made that can actually query a whole file, maybe a huge file, and then it's able to calculate how much maybe memory that the application will be able to upload, and then see whether my limit is usually around 8 GB. So if I know this file might exceed the 8 GB limit, then my application might fail. So much of my debugging is usually actually off data, and it's hard to use, I think, profilers for that. So yeah, basically that. And another unfortunate thing about using off-heap data is that you cannot depend on garbage collection. I've tried to use that. Maybe I need to now use the official APIs Java has, like the cleaner class, but you have to explicitly manage your memory. Like if you're done with an array, maybe an off-heap array, you have to release it manually. And actually knowing how Java actually executes, like most local variables in a method, they're never released immediately. Actually, it's something I realized. So using a cleaner might make some data remain in the RAM, so you have to release it manually. So yeah, so based on experience, that's how I actually know how my application works. So on heap memory, I don't use it much often. So yeah, that's the reason why the profilers I don't use them much. Yeah. But the one I tend to use once in a while is the one from NetBeans, because I use NetBeans actually. That's why I started, and I've never left Maybe one day I'll upgrade to maybe IntelliJ. Is it IntelliJ ID? Yeah, maybe, yeah. Thank you.
Oh, I think you and Gosling.
Oh, okay, yeah, yeah. I've never met any NetBeans user, so yeah, yeah, that's interesting. Okay.
Yeah. So for us, yeah. Okay. Thank you. Yeah. So when IntelliJ came, we all ran away from NetBeans, but we all started from NetBeans. I started from Eclipse. I remember getting my first laptop and seeing that Eclipse logo, and I didn't know anything about what was behind that splash screen. And from Eclipse we moved to NetBeans. I'm sure almost everybody in this space experienced the NetBeans for class assignments from lecturers they hate. So but some people stuck with it over the years. So I think that's very interesting. Yeah, I mean, I'm glad to get that interesting perspective of, there's some domains, there's some use cases where you actually shouldn't use a profiler because it doesn't make sense for the domain. So that's something interesting to know. And I'm glad that you don't use the memory heap because there's this problem that they always tell us: the CPU is smarter than you, the compiler is smarter than you, JVM is smarter than you. So you are here in the application layer trying to do optimization, but there's really intelligent, smart people have already done optimization on the compiler, on the CPU. If you see some of the work that Intel is doing, where they have like some machine learning concepts within their some of the sections of the processor, and they're able to do some interesting branching thing. They have a series on YouTube for anybody who's interested. There's a course that Intel has released. I can't remember the name. I'll try and link it here, where they teach through like I think 5 videos. They teach how their CPU architecture works, and they use like real world examples. I think it's very insightful. You're able to understand how your program is executed. So when you're seeing some inefficiencies, you can try to maybe reduce. One thing that I take away from their course was you should reduce branching because the CPU doesn't handle branching very well. So the CPU tries to predict the flow of execution of your program. So the less branching you have within your code, the easier the CPU is able to plan the execution. But if you have a lot of branching, a lot of conditionals, then the CPU has to do a lot of guessing, and there's a percentage of the guessing that they get wrong, and the CPU has to walk back and begin your execution from a particular label. So I'll try and link it to the space in the replies here so that you guys can also check it out. But it's a really good course that they provide, and it's fully funded. So I think that's very interesting. I don't know if Joe, are you familiar with that course?
Oh, no, but what you've talked about branching, I'm actually surprised. It's something common in CPU. In GPU, it's quite sensitive. Actually, if you introduce branching in GPU, your program can even actually stall even your computer because it slows down everything. Yeah, so branching, you have to avoid it completely as possible. So I didn't know actually it has some performance implication in the CPU. Maybe I thought it was the compiler maybe knows how to optimize that, but in GPU it has been a headache. So I discovered that some programming architectures like CUDA, programming platforms like CUDA and OpenCL have provided way of dealing with branchless scenarios, branchless scenarios, where you convert a branch into a branchless scenario. And actually, the headache of branching can actually make you frustrated when writing such kind of programs. Yeah. I'll look at it actually. Yeah, that's intriguing. Also, yeah. For CPU.
Yeah, it's very interesting because, and I think that's another point we need to address. Is by understanding the hardware where your software is going to be deployed and the constraints that you have to deal with within that target hardware environment, it helps you to more consciously write your software, because you can be able to say, okay, yeah, this is kind of CPU architecture that's being used there. So some of us who are running servers, they mostly ARM architecture, and you can try and see, even your cloud provider will tell you the specifics of the kind of hardware that they're providing. The CPU and memory are being included. So that allows you to like plan out and see where you need to do optimizations. And but the specs are usually really high when it comes to servers. You'll get like some crazy SSD drive with some ridiculous speeds. Maybe if you're lucky, you get some really powerful virtual CPU or dedicated CPU. You control how much memory you want. So I think in the server space, it's less of a concern, more of if you want to save money. Now you don't want the server space the cloud provider to basically eat up all the profit if you're getting, all the money if you're getting any from the service you're providing. So that's why you might look into this. But for me, I was more interested because of the mobile environment. My colleagues who are in the space who would like do mobile development, Android, iOS, you guys know how painful it is working in mobile. You have to be very, very careful about how much data you are storing in that local cache, how many operations you are running, because you're sharing this small hardware device with so many other applications, and some of them are misbehaving, and for most of them also, you find the operating system itself is not optimized. Like maybe if you have Android, you're running something other than Android Go. If it's not Android Go, they haven't optimized it for performance at all. So if this guy is running the actual Android OS distribution on a memory constrained device, maybe nowadays memory constraint is like 2 GB. It's ridiculous. Back in the day, memory constraint used to be like 100 kilobytes or 40 kilobytes. But try running an app on a 2 GB Android phone, and you run it on like a flagship Samsung S series with like 8 gigabytes. It's a completely different experience, and you kind of have to be aware of that. So you'll find the operating system has some inefficiencies that come with it. They might not even be your fault; just the OS is not well optimized, and now you have to carry the burden of trying to optimize your applications that is able to run on these systems efficiently. Before I forget, let me just link that course. And I think we are gotten to the end of the space. I wanted this to be 1 hour, a 1 hour thing. Yeah, so as we conclude, I think if you guys don't want to request the mic, you can just reply on the space itself there with a question or anything that you may want me to talk about in the space before we close. Because I want this to be as interactive as possible so that we can also hear from you guys. I see Derito mentioned something about Kotlin having value classes as they were to Valhalla. Yeah. Of course, Kotlin inherits a lot of things from the JVM because kind of run within the same environment as Java. So I'm not surprised that they'll do something with this. For any Android fork in the space, there's this thing I discovered where anytime you create arrays in Kotlin, they are automatically boxed. So if you create an int array, it's automatically converted into an integer of object type integer arrays. Just something interesting, but the good thing is well documented. So if you're, we usually use arrays when you want to like get high performance for your algorithms. And you're processing so much data that you need to introduce efficiencies that you don't get any memory issues. But it was interesting that Kotlin kind of eliminates that by taking those primitive types and converting them into object types, basically something we call boxing. But they have it documented that they do this, and they provide some other data structures that don't do that. So you kind of have to prefix the initialization of the array with like int array or car array as that. I tweeted about it, I think, yesterday. So that you're able to explicitly tell the compiler that, oh, please don't convert this array into objects. I want primitives. So that was something interesting that I observed. I think I think I'll give this a minute to see if there's any question. You guys can just request the mic if you want to chip in. I want this to be as open and interactive as possible. So if you have any thoughts, anything you'd like to share with the people in the space regarding performance tuning, this is your opportunity. I've shared the course that Intel did. It's called Architecture All Access, Modern CPU Architecture. I think it's a 5-part series. It's on YouTube. Let's see. If you find the playlist, I didn't find the actual playlist, but you guys find the playlist. It's like a 5-part series, and they teach some very, very, very interesting concepts there that allow you to understand the kind of hardware in which your programs execute. So, any questions, guys, before I give it to the speakers to give their final word as we finalize, as we close? If you're afraid of speaking directly, you can just reply there, and I'll pick it up from the reply. I've pinned the space tweet on my Twitter feed. So, oh yeah, there's a request. Okay. Yes, Johnny, let me know if you've. Okay. I've enabled you, Johnny. Can proceed. Johnny, the space is yours. The floor is yours. You can proceed to speak. Yeah.
Hello.
Hello, I can hear you. I can hear you very well.
Hi. Hi everyone. My name is John. Thank you, Samuel, for hosting this space. Yeah, you've mentioned a number of good pointers for at least anyone trying to get into the space where they want to optimize their code. So about me, I'm a software engineer with one startup here in Nairobi. I'm kind of I've been getting into the optimization space since 2021, where I was working before. I had an interesting experience. We had a system which had a lot of data, 230 GB of data, and we wanted to optimize fetching this data because there was a lot of reporting and also customers fetching their own data. So since that time, I've been studying or trying out things on my own. One thing that I took away from that experience, I'm very happy that Enoch has mentioned it, is database optimizations. They can slip away from you, but it really means a lot for your application. Check your indexing, check the sizes of the data that you're storing. You can also learn about some databases that perform quite poorly, especially when having a lot of load. Case in point, my personal experience has been MySQL. Once you hit some threshold, its performance dips quite a bit, from my own experience. So you have to start thinking of sharding your data, like truncating your data also as an option of relieving the stress on that database. You're working with SQL Server, it hogs a lot the threads, computer threads. So if it's running on a server, it takes up a lot of threads, and you can max out the threads. Then you'll have locked requests, or a request will come in and it will take minutes to process. That's just something maybe everyone maybe can look into. Database optimizations, it's also another way you can optimize your applications. It can save you a lot of money, especially when hosting on these very, very, very expensive cloud services. Thanks.
Thank you so much, John. That was very insightful, and I think very critical also. So if you're running an enterprise product where you're storing a ton of data, and what we usually quickly learn is immediately when the database gets huge, the operations that used to be negligible in terms of how long they took quickly become a problem. And I'm glad you mentioned indexing, sharding, choosing a reliable and fairly faster database management system. I think those are some really good actionable things that somebody can just jump into and optimize that particular area. Of course, just like we mentioned earlier, maybe I can add on that is if there are things, MySQL, just like you mentioned, MySQL can become very slow, very fast, especially if you are storing a lot of data. So if there are things that you can store as key value pairs that you're just using to do some repetitive operations within your within the product or within your business logic, you can offload those to an in-memory cache. In this case, like Redis. I don't know if there's another in-memory cache. I think there's one that Facebook rolled out. It's very common, but I can't remember the name. I think I only know Redis and that one that I can't remember its name. But there's a few in-memory databases that you can use. And with this in-memory database, you can actually do a distributed system where you have a few of them in particular instances, and you can be like mapping the data across them. That leads to a very complex system. I think for me, I've just been using one in-memory cache. There's one thing that we were discussing with Brian. Brian Osoro is in the space where people have decided to use these in-memory databases as primary databases. I don't see how that's possible because it's in memory. Once that server shuts down, that data is capiche, it's gone. So I don't know how people are able to do this. Maybe replication or something. Yeah, but that's one way people are combating this issue. So I'd like to give it over to Musioka. Musioka, thanks for coming on. The floor is yours. Let's hear from you.
Hi guys. I hope you can hear me, right? Samuel, you can hear me?
You are very, 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 very clear. Thank you so much.
Okay. Thank you. So my name is Musioka, and I've actually shared something on the chats. Is that conversation I joined today because this usually that concern mostly in Android ecosystem. Where there seem to be some thin line between optimization, scaling, and over engineering. Mine is a question or a concern. What's your take? What's your take on that? And guys who have been in this industry for many years, like you, Sam, what's your view on that?
Thank you for the question. I think I'll answer it and then I'll pass it over to Joe and John. If you're open to this, I already lost Enoch, but anyway, I would have also passed it over to Enoch to also hear what his thoughts are. But yeah, I mean, I think I've developed some high-profile enemies, people we disagree with because of my ideas on over engineering. Because I'm really against over engineering. I think software program should be as simple as possible. It should be, you get a toddler from pre-1, they should be able to understand what you're doing, either through the code or through in the way you've just structured it. But a toddler is an extreme case. But basically, my point is it should be as simple as possible because you're already solving a complex problem, which is taking this technology and use it in a real world use case. Because the interesting thing with our profession is we are not like astrophysicists. We don't talk about hypothetical things. We are not talking about some stars that are billions of light years away from us. We're talking about a rudimentary, old school organization with employees, with customers, with suppliers. At the end of the day, that's what most of us are doing, unless maybe you're working at NASA or something. So the nature of the problem that we're dealing with involves human relationships, and human relationships are very complex in themselves. Like the case I was talking about, employee, supervisor. That sounds simple, but you should talk to people who are doing ERP systems. Those guys are pulling their hair out because the domain, the systems that they are building are become very complex very fast. So now when you take that complexity, which is the human aspect of the software product you're building, and then you double it up by having engineering complexity in the project itself, then you've doomed yourself. People haven't liked my opinion on this, but I've seen this in mobile where you go to a code repository, and this code is doing something very simple. It's a simple app that I see it with the guys who are doing like portfolio projects. Not all of them, just a few. But in Android, I could say like 90% of guys do this. So yeah, it's a movie streaming app, like a concept application. But then you're like, okay, this is nice. So let me see which part of the code stores the movies. Then you go to the code base and you find a router, you find a module, you find some database dependency injection constructs. You find, of course, you find modularization, just like I said. Then you find there's a package called maybe scope or use cases, or then you find there's a networking package and it has some networking code. So you're like, okay, so where is the movie aspect of this code base? Where is the business logic? Because at the end of the day, that's what's important in that code base. So people end up surrounding themselves with this excessive complexity that now even addressing the domain problem becomes a challenge, because you have to build all these things around the product before you can attack the domain problem. And I think that's unfortunate. It shouldn't be the case at all. I'm envious of web guys because they've managed to eliminate complexity, not increase it. So if you look at a Vue app, they've eliminated creating a CSS file separately, maybe creating a JS file somewhere else. I don't do web, so I could be wrong about this. And you'll find that they have that small section where you just do app.js and then you run it and then it runs the application, the UI and everything. I like that, where the complexity is hidden. It's not something that you have as part of the structure of your code. The code should represent the domain problem you're dealing with. If it's a movie streaming app, let me see, series, movies, new releases, or the function that's actually streaming from maybe streaming providers, Netflix, whichever provider is there. Let that be represented in the code base. Let the code base represent the domain problem, not some architectural idea. Not to name names, like MVVM is very common with this. I don't use that architectural pattern. In fact, I don't use any architectural pattern. The only architectural pattern that I deal with is what is the real world problem and how does that map to the software? Because those architectural patterns were supposed to give us an idea of how to represent real world problems in software. They are not prescribing exactly how every code base should look like. Because let's be honest, we are solving very different problems, very different domains. So the moment we have code bases looking the same, then already we have a problem, because these things are solving completely different things. So if they all look identical, then it limits your ability to solve for that particular domain. I could go on and on about this, so I'd like to hear from other guys what they think about this over engineering thing. Joe, what are your thoughts on over engineering?
Okay. For me, I hate complex code actually. There's somewhere I saw there's a guy on GitHub, JavaFX. If you want to display maybe 1,000 data sets, maybe like a list of 1,000 elements to any user interface. For example, if you use a list, for example, to display 1,000 elements, there's usually a framework called virtual display, whereby you only display the 10 elements and then the program calculates. When the user scrolls down, the program calculates what number of cells to display, etc. So the JavaFX library, apparently it has 3,000. The functionality to do that, it has like 3,000 lines of code. and the guy in GitHub was able to develop his own to around maybe I think 300 if I'm not wrong. And actually, it's a very popular virtual flow program. So for him, he was annoyed by the complexity of implementing a simple thing because of too much clutter in the code. So he had to implement his own approach so that he can develop his own JavaFX components. So in this case, for me, I believe the architecture or the framework you're going to use to develop a specific library should be as simple as possible. You should be able to comment what each function works. There's a meme I saw here that someone left a comment in a legacy method saying that this function is not used anywhere, but if you decide to delete it, the program crashes. So therefore, I'm leaving it here. So it's good to comment code and also maybe also provide a feedback on how the program is, how it has been developed, the approach on the development of the API, etc. So for me, simplicity is it's really important. I think that's why it's old school. Okay, the hardware programmers prefer C code because C code doesn't have a lot of features or ways of actually the way modern languages try to come up with new language features, etc. Yeah, so it's easy actually to for me it's easier to read C code and even Java code, but nowadays people use very long names. It clutters the code a lot. But yeah, for me, I believe in simplicity. And I don't know whether people watched the recent Java Language Summit that happened, I think a few weeks ago. Bram Goetz actually gave a very nice talk about the API he's developing for the for the class. Is it called the class file API? For programs that tend to inject code in existing compiled classes. So there's no proper API to do that. So he gave an explanation how they developed theirs internally. And actually, most of the comments here are like, he knows how to explain things. And anyone who wants to develop API should actually watch this video. So I'll share the link on the chat, and then you go and listen. But it's quite insightful. Yeah. So thank you.
Thank you so much, Joe. Yeah, so simplicity. Let's keep things simple. But I understand. I also have to walk back from my comments because some of us are doing this for job interviews. So maybe you'll do it for the job interview, and then you get to the job, and it's a legacy, 20-year-old XML-based, very old system that doesn't have MVVM at all, and they were just using MVVM to interview the candidates. So yeah, I mean, I have to also I empathize with the people who are doing this for like concept applications. But if it's like an industrial production application, I think the main philosophy that I hold dear is your software project should map the real world problem you're solving. It's not mapping that real world problem, then you're just making, it's like chasing your tail. So I have Brian Osoro in. Musyoka, do you want to add something on the engineering, maybe respond to our comments, or should I hand it over to Brian?
You can hand over to Brian. That was really informative, and yeah, thank you for that. So over to Brian.
Hello guys. Thanks Samuel for the invite. Why I wanted to jump in on Musyoka's question was it was something that my approach is usually being what can I say, empirical, and which is might not be within what what is out there, because now you'd see companies like Google giving best practices, and once or twice, maybe 4 times, I've seen Google retracing what they called best practice, And so I think I established that these best practices are just moving targets. And these days it's like the theme is less verbosity. So the less verbose something is, the better. And the more declarative something is, the more wonderful it is. Which is, it's context based. But now when you start looking at, as Samuel was saying, there are some people who might, get this wrong. But like I'll pick an example for those who do Android, especially with this overcomplication, using of, I don't know, you hear dependency injection framework has just come out, you think it's the best thing, and then you almost immediately you notice your build times, are a bit slow. The whatever, the APK or AR file becomes a bit big, and then you might think, okay, maybe this is me doing it the wrong way. But if you decide to be more empirical and run benchmarks, you're going to see why companies, for instance, let me say Pinterest, why they actually had to stop, some of these new things and go back to your XML from Jetpack Compose. Because there's that, especially if, I feel like if your interest is performance, as compared to what is new, you might look at this in a different direction. But this is not to say that they are bad things. I feel like whatever is presented to anyone as a best practice or whatever, new framework, you might need to take time by yourself to interrogate by way of, running benchmarks and etc. Because there's a time I wanted to understand why are people doing all this. Then I noticed, as someone was saying, job interviews. Now it's like the more you can complicate your code, now you deserve this job. And then now, what is simplicity? I feel like that's very subjective, because to other people, simplicity is, can I look at this concept and I understand what this person was trying to represent? Another person will talk of architecture of, are we using a layer-based architecture, or are we segmenting or rather packaging our code base in terms of the features? So I don't know. It's just keep it simple. That's what I'll say.
Yeah, thanks, Brian. I think it's something that I think even guys in the Android ecosystem, I think they have gotten to a point where they appreciate this. Architecture should be descriptive, not prescriptive. And I think with MVVM, it's prescriptive in the sense that it becomes invasive. If something defines exactly how your code structure will look, up to the fine-tuned, fine-grained details, then it's a problem, because it doesn't give you that freedom to address the kind of software problems you've been presented. Because like I said previously, every domain problem has its own unique issues, because you are representing human relationships. And we know here human relationships are very complex. So if every code base looks the same, I think that is definitely, it's not great. I don't think it's even sustainable. It's not something that we should advocate. I think MVVM comes from Robert Martin's book on clean architecture, and the way I think about it is, if you look at clean code, which I think that's his first very popular book on software development. There are things that he suggests that they are not invasive in themselves. They allow you to still structure your code. There are more suggestions, like you should name your functions properly. Your function should do one thing and one thing only. Those are things that, they are suggestions in the back of your mind as you're writing code, but they're not telling you how you should write your code. When somebody tells you your function should do one thing and one thing only, they have not told you what that one thing is. But if you look at clean architecture, it tells you put your networking components here, put your use cases here, put this here. So then it's prescriptive. It's like telling you exactly what to do, instead of giving you like, these are the best practices. But you are the engineer, so look at the domain problem and determine what to do. And for me, generally, if any software within like coding, if anything is invasive, I avoid it. If it comes into how I've structured my code and forces me to restructure it, then that's a problem because I've structured my code to map the problem that I'm trying to solve. We've received some comments for guys who are not like who don't have the mic on the same thing. So Dr. Natkes there says, I think then over engineering is expensive in a way in the long run, which we have to agree with because you end up creating technical debt. The more overcomplicated the code base is, anybody who's like doing a real world software project, they'll bring that intern and you have deadlines and then they tell you, okay, this intern is tied to you. So you have to show them the code base and how it works. And also you have to meet your deadline. So the more complex this code base is, the more you have to sit with this intern and the more they have to bother you with questions like, oh, and what does this networking thing mean? And what does this mean? So if the code base is simple, you can tell them, okay, this is the general structure and this is how you approach this. And if it's simple enough, then, one session with them is enough for them to like pick up and be able to address their first issue. So in a way, you're also helping yourself by keeping the code base simple. When it comes to doing comments, you do comments only when you're like, somebody will not understand what I've done, which, that should be a signal that you've structured that code, or that at least that section of the code, you've structured it incorrectly. So if you don't have time to like restructure it or whatever, you can leave a comment. But usually a comment is to a degree, we can debate this, but a comment is a bad code smell. Like the moment you leave a comment, there's something you did wrong. That now you have to tell people that, hey, that place, this is how it works. Or like Joe was mentioning, where you say, I don't know what's happening here, but if you remove this line of code, the whole system like collapses. So yeah, I agree with you, Dr. Natkes, on that. So Edith is asking, does anyone here know someone or is someone who owns a laptop that is not in use and would mind donating it? Your response will highly be appreciated. Thank you. Yeah, so there's somebody in the comments asking whether somebody has a disposable or laptop they're not using. So if any of you guys are interested in that, you can reach out to Edith. Yeah, so I'm not seeing any other questions. So I think I'll hand it over to the guys who have contributed to the space and anybody in the space who'd like to give some comments. But I'll start over with our speakers to give their closing remarks and then I'll give mine after that so that we can end this one and see what's next. So if you're in the space and you want to give some remarks, this is your chance as our speakers give their closing remarks. So I'll start with we already lost Enoch. I hope Enoch figures out his internet the next time so that we're able to hear more from him, but it's okay. So I'll start with you, Joe. Maybe you can give your closing remarks before we end the space.
Okay, thank you, Sam, for giving me this opportunity to discuss about programming actually, and we have been interacting with you a lot on Twitter, and I usually see the passion you have with programming and also trolling other programmers. It's usually quite hilarious. Anyway, but it's good to see many Kenyans actually being involved in programming, and it's good to have home-based it's actually good to have programmers, because back in the day we weren't given these opportunities to learn about programming, because for me I'm self-taught, and programming is all about passion. It's not about maybe going to school, study, and then you say you're a programmer. Most of you here, it's all about passion, and it's quite evident, and you're actually most of you are actually doing great projects. I'm actually impressed. So I'll actually urge Sam to continue this kind of conversations, so that we encourage more Kenyans actually to be interested about programming and to see how programming can actually transform lives based on businesses, projects, and many other things. Yeah. So yeah, but it was a privilege to be invited here, and thank you very much. Yeah.
Thank you so much, Joe, for honoring the invitation. This is like episode 0, so we didn't have any background. So the fact that you are willing to like take this chance, this risk with us, and try to like do something new, if we can consider this new, I think I'm really grateful. Thank you for coming, bro. Thank you so much. So I'll hand it over to Musyoka. Musyoka, say tell these guys a few things as we end this space.
Okay, thank you. So mine was a question, so I don't know if I was a speaker per se, but all in all, this was informative. I do care about performance systems and well engineered systems. So a platform like this it's one of the few things, one of the things we lack in our tech ecosystem. So if we go this way, I think we'll have better perspectives in terms of not just writing the code, but ensuring whatever you're building is it's performance, solves the problem, and does not bother the user when solving that problem. Yeah, so thank you so much for this.
Thank you so much, Musyoka. Brian, any remarks, Brian?
Oh yeah, mine was just to respond to what Musyoka had asked, because it was something that had taken some time in looking at, especially now that more than ever we are having new frameworks coming up, and very few people are talking about performance. Everybody seems to be talking about verbosity and how easy something is and how easy it is to do something, as opposed to, is this the right way? Is this the right approach? And so basically performance-led development, as opposed to, the other niceties that are presented. Yeah, so I think this is as Musyoka was saying, this is something I feel like it will be relevant, especially for people who might want to get a different perspective from maybe people who have been doing this for quite a while. Yeah, so I think this is a step in the right direction. Thanks, everyone.
Thanks, Brian, for the vote of approval. I hope we're able to do more of this, and of course explore topics even beyond performance tuning. There are various aspects of software development that we can share, and helps us to be able to address things faster. So you're not like on your own. You can see what other software developers are doing and kind of try and put that into practice. So there's something that you've mentioned regarding the campaigns to eliminate verbosity. As a Java programmer, you can tell the pain in my voice when I say that, because we are the ones who are accused to be the most verbose programming language on the planet. So it's something we deal with. But we have starting from Java 21, there's no more public static void main. Although that was my favorite part of the Java programming language, it has been removed, so no more public static void main. But we still have system.out.println, which is still my favorite part. At least they kept that one, so I'm excited. I hope they keep it for long and we don't become Python by doing println. I would not be happy. Anyway, so there's something you mentioned about verbosity, and guys on the space on the replays, we've been sharing some resources. There's a resource I shared. There's a talk that was done by Molly Rocket. He's very vocal on performance tuning. He's a games developer, very experienced, by the way. So I've shared his talk. The talk's name is called Clean Code Horrible Performance, where it looks at clean code concepts from that book by Robert C. Martins, and looks at how, when you follow the constructs in that book, how it affects the performance of the resulting code. And he goes into some very detailed analysis of that. So I've shared it on the replies. You guys can find it there. But it's one of those talks that you should watch. It kind of opens your mind up to a few things that you might otherwise not be too much into. So I think that marks the end of our space today. I'm seeing guys are joining now, so I don't know if we should start another space or something. But we are still having another one next Friday. So and also this one is recording, so you guys can listen to it after the review. Or I hope I'm recording. And this is my first space to host, so I'm not 100% sure how things work here. But I hope it's recording so that you guys can listen to what we're talking about during the space. So I think I can do a summary as we close. So on this space, we're able to look at a few aspects of performance tuning. We heard from Enoch. Enoch builds betting systems. And those are high performance, high availability systems. So he was able to share a few concepts with us on how to ensure reliable and fast or performance system. And of course, Enoch mentioned message queue, using a message queue, using an in-memory cache, namely Redis. He mentioned using some logging services like Sentry. I think that's something that I think some of us can look into and see whether we can apply it in our day-to-day to see whether we can make our systems more reliable. Then we had Joe, who works in if Joe, you allow me to call it graphics programming, because that's the one that my mind can comprehend. Yeah, but it does ray tracing, and for that it's a performance critical domain of software development. So he was able to share a few things about how he approaches performance tuning, a few challenges that he's been facing, and how he has been addressing that. He mentioned some projects within the Java ecosystem, Project Valhalla, Project Panama, and we've linked some of them in the replies there, so you guys can check them out if you get time. I was also curious to hear whether other platforms have similar things going on. So the next place, maybe if any of you guys, maybe you're working in PHP, you're working in Ruby, you're working in TypeScript, Node.js, if you guys have any of those constructs happening within your ecosystem, I think the next place you can share with that, share that with us, and we can see how we can compare and contrast. That's why laws are usually exposed. When you compare and contrast, you're able to see oh, this guy's got this correct, and this guy's missed this and this. And for us as programmers, we're able to, having that knowledge helps you to do better when doing development. We talked about Java byte buffer, using unsafe classes, and debugging memory usage. And I think there were some insights on that. So Joe has shared resources on the reply, so you guys can check out that. Yeah, so I think that's it. We can go ahead and close the space. Thank you so much for everybody who joined. If you have any questions, the discussion will continue on the TL. Otherwise, thank you guys so much for joining. This is my first space to host. I was very anxious about it, and I'm glad it went well. So thank you so much. I wish you guys a wonderful weekend, and thank you for joining. Bye. So you can leave at your pleasure. But thank you for joining. Thank you.